So what we are trying to do in particular values, like I wrote in this introduction, is that when do you talk about integration, you are trying to reverse what differentiation has done, isn't it? So when you find the differential coefficient of a function, you are trying to understand what will be the gradient at any point x. So there will be a function that can tell you what the gradient will be at any point x. So we call that the gradient function, isn't it? Now, you will notice that some curves, family of curves, will have the same gradient function. For example, if I have x squared plus 1, x squared minus 4, or even x squared, even if I have like maybe x squared plus 2x minus 1 plus 4, x squared plus 2x minus 7, they all have the same gradient function. Okay? For each of them, the only difference is this. They all have different intercepts on the y-axis. So their gradient function for each of them is simply 2x plus 2. So for each of them, when x is 1, the same slope. When x is 1, the same slope. When x is 1, the same slope. For each of them. So which means if we are provided with 2x as the gradient function, it is difficult to pinpoint which of these curves we are dealing with. Understand? So that is why the particular value problem can help you to pinpoint which one specifically you are dealing with. Because without the additional conditions that the particular value problem will bring in, you are actually referring to the entire family that gives you the derivative 2x at any point x. Which means for curve A, at x is equal to 1, the gradient is 2. For curve B, gradient is 2. For curve C, gradient is 2. So if you want to go back and say, oh, there is this curve that gave me gradient 2 at x is equal to 1, you'd be like, okay, in our family we have 4 children. Which of the kids are you talking about? Do you understand that? But you can now go further. Oh, the one in P3, that's additional information that we know, provided there are no twins in the same grade anyway in the family. Do you get my point? So that's the whole essence of the particular value problem. It's just what you have done with substitution, basically. So we start by saying, if this is f prime of x, we are interested in f of x. According to that question, this is question 6 of the worksheet. It says, given that f prime x is equal to 3x squared minus 4x plus 1, and f of 0 is equal to 2, find f of x. So we're interested in f of x. Okay? Are you listening? We're interested in f of x. So our f of x, so this is the first thing I need you to write. F of x will have been integral of 3x squared minus 4x plus 1 dx. Do you agree? So this f of x will have been 3x cubed over 3, 4x squared over 2, x plus c. So I could write it as f of x is equal to x cubed, 2x squared, and x and c. You see, for different values of c, you are referring to different curves. But with this, you are referring to specific curve. Then you substitute. Okay? So f of 0 is equal to 2 implies that 2 is equal to 0 cubed, 2 0 squared, c. What does that tell you? C is equal to 2. Therefore, the function you are talking about, the particular function you are talking about, among this family, this is a family of curves, parallel curves, if we may use that terminology, is x cubed, 2x squared, x plus 2. Now you are getting specific curve. That's all. You can see it's not a new idea. It's just a combination of what you have done before with substitution from lower grades. Okay? So, similarly, I picked these two for obvious reasons. This consists of many variables. Let's have some time. So let's start with this one. Again, from here, f of x is equal to the integral ax squared plus bx dx. Every integral must be ended with dx, otherwise we don't know with respect to what. So this will be, together, a
x
cubed over 3
plus bx squared over 2 plus c.
6. Okay, so this is your f of x. That's why you have 3 different values, because now there are 3 different variables. Okay, so f of -1 equals -2 implies what? When you put -1, a -1 cubed over 3, b -1 squared over 2 plus c is equal to -2. So we form equation ABC. This also you form equation ABC. You might be lucky here that C will be given already. Agree? Because you have 0. So C can be given from here. So once you get C from here, put it in here to reduce it to A and B. And to reduce this one also to A and B. Then you solve the last two simultaneously. I want to believe you can handle this. Okay? And the last one. Can you see the uniqueness in this problem? You are not given the gradient function. Rather, you are given a function that describes what? That describes what about the curve? The curvature. Second derivative tells you the curvature. Is it minimum? Is it maximum? Does it change somewhere? The rates at which the gradient changes. That's what you have, not even the gradient itself. Okay? And there are a lot of curves that will be like this also. So we start by saying, what will be the first thing to find?
F prime of x.
The first derivative, right? Good. So you say f prime of x will be the integral of 2 plus sine x dx. That's the first thing. Which means your first derivative is 2x. Integral of sine is minus cos. And luckily there's no other additional stuff, so you don't divide. So you must not forget all those details. All the rules are being combined now. Then plus c. Then check. Do you have any information regarding f prime?
Yes.
Yes, we do. In some cases you don't have it. In some questions here you have f of something twice. Which means you continue to differentiate until you get maybe plus cx plus d. Understand what I mean? The first gives you c, right? If this information was this way, it means I'm having particular values on the function, not on the gradient function now. Which means I'll continue to differentiate and integrate. Then I'll end up having cx plus d. This will be my arbitrary constant now, because the c has been used. Am I making sense? But that's not the case here, because this is what you have. So since this is what we have, you can use this first to find out what c is. Then you continue the process again. So f prime of pi equals 1 implies that, together, 2 pi
equal 1.
What is cos pi? That's cos 180. What's that? -1, right? So this is 2 pi minus 1 plus c equals 1. Can you see that? So which means 2 pi plus 1 plus c equals, or I can just say minus 1 is equal to, no, I don't want to use minus c again. It's okay. So c becomes 1 minus 1 minus 2 pi minus 2 pi. Agree?
Yes.
So which means my gradient function of x, it can be written as what now? 2x
minus cos x minus 2 pi.
Good. Then you proceed again. As a result, you say, yes, this implies this. Which implies that my function itself will be integral,
Of 2x.
2x. Please always write this integral stuff, okay?
Minus cos x minus 2 pi dx.
dx. Okay? And that will be, yes?
2x squared over 2.
Minus
Minus
Sine x.
minus 2 pi x
2 pi x plus c. You can use your c again because the first one has been done. Okay? And if you don't want to mix up, you can say plus k. It doesn't matter, it's just a constant. Then this is f of x. Then you use the second value. So f of pi over 2 equals pi squared over 4 implies, yes, 2. Oh, this should have been simplified.
Yes.
Please always simplify. Apologies. So this is x squared sine x 2 pi x plus c. Miss V, can we see all this?
Yep.
Okay, so f of pi over 2 equals pi squared over 4 implies, yes, together?
Pi over 2
Pi over 2 squared
minus
sine pi over 2, 2 pi over 2 c equals pi squared over 4. Pi squared over 4, pi squared over 4. Right? This is gone. What is sine 90? 1. Right?
Yes.
Pi over 2 is 90, sine 90 is 1. And always check in the calculator. And this is what? Pi squared. Agree? So you are left with minus 1 minus pi squared plus c equals 0. Yes? So when this 2 goes to the other side, your c is equal to 1 plus pi squared. Then your f of x is what? Yes, together?
X squared
X squared
minus sine x
minus sine x
minus 2 pi x
minus 2 pi x, yes,
plus
plus 1 plus pi squared. That's it. That's all about particular values. Please practice as much as you can. We don't have class tomorrow, yes? I'll select some problems from particular values as graded homework. I'll post it to you later. Thank you.